Okay, so in this section, we're going to take a look at the basic circuit measurements. We're going to look at how we handle measurements using voltage, current, and resistance, and some of the basic setup and readings for the specific meters. So in this case, you can see we've got three little depictions here for an ammeter, two for a voltmeter, and one for a generic ohm meter that you will encounter in your reading in the textbook. And looking at different ways of making measurement, let's first take a look at doing a simple current measurement. With a simple current measurement where we have a resistor and a battery in series, with a current measurement, we actually have to break the circuit. So in this case, we're going to undo the alligator clip off of the resistor and open the circuit. And where we open the circuit is where we're going to insert the ammeter so that we can measure the current. Okay, so we have to have current flowing through all of the devices to get a current reading. This will be the total current in the circuit. So in this case, you see we've got an ammeter generically connected to the resistor and the source. For a voltage measurement, you don't have to change anything. All you have to do is place the measurement leads across or in parallel with the resistor, and in this case, whatever voltage is across that resistor is the same voltage as the source. And you're going to see that again as we progress through the course. Finally, making a resistance measurement. In a resistance measurement, this one requires that we disassemble the circuit so that we have isolated the resistor by itself out of the circuit. The reason for this is when you make a resistance measurement, the meter will try to take the resistance for the entire circuit. So we isolate the resistor and make the measurement. Why would we do this? Well, maybe you have a defective resistor and you want to remove it and see if it was burned open, if it's opened, it's shorted, whatever, and you can tell. Or if for some reason you couldn't tell what the value was and you wanted to make a measurement. Digital meters, DMMs. DMMs are very, very helpful. You'll be using them a lot in the lab, whether it's a handheld or a desktop or a bench meter. With the DMM, you'll be able to measure voltage, current, and resistance. The output of a DMM gives the meter its name. It has a digital output. So across the 7-segment display, you can see the format here that will read everything from 1 to 0 in the display. Changing the resolution. Changing the resolution is kind of like accuracy and accuracy and significant digits. With this resolution set, depending on how much accuracy you need or want, 0.99 can have the same value without changing anything as 1.00, but that's not going to be as accurate. The same with the second two, 1.99 or 2.00. So you have to set your resolution based on what type of accuracy you're trying to measure in any given circuit. With an analog meter, you may get an opportunity to use these. An analog meter is a meter that has several scales on it. You have to select the scale that you are going to use to make the most accurate measurement. So there are a lot of folks out there that prefer an analog meter to a digital meter, and there are some other reasons why you might want to use one, like loading and things of this nature to a circuit. So you select the scale that you want to use, that you want to measure based on these values: DC volts, AC volts, ohms, and current on the side. Okay. In reading analog meters, the ohm scale, and you can see the ohm scale down here on the bottom of the meter itself. Ohms are read on the top scale of the meter. The scale is nonlinear. That is, values are represented by each division, small or large. You can vary then as you go across the scale. To read the actual value in ohms, you multiply the number on the scale as indicated by the pointer by the factor selected by the switch. And the example here says when the switch is set at times 100 and the pointer is at 20, the reading is actually 20 times 100 or 2000 ohms. Okay, so when you're in the lab, take some time, use an analog meter. AC-DC scales, again, if we go back to the meter, you can see our AC, our DC, and our current there, DC milliamps. The second, third, and fourth scales from the top are labeled AC, DC, and used in conjunction with volts and AC and DC. Okay, and again, you use the same times indicators on the meter itself. If we look at an example here, we've got a meter face and we want to read what the value is. So determine the quantity, voltage, current, and resistance that's being measured and its value for each specified switch settings as depicted. The switch is set to the DC volts function and 60 volts. And if we take a look at this, we can see that the reading taken from the middle scale is 18 volts. Okay, so we're looking here at the middle scale and we would read 18 volts. The switch is set to milliamps DC on the 12 milliamp range. The reading taken from the AC-DC scale then is 3.8 milliamps. So here's our DC milliamps over here, and we're at 3.8. And finally, the switch is set on the ohms function at times 1000. The reading taken from the ohm scale is the top at 10,000. You can see the end of the meter needle here is setting right at 10, and the 10,000 or the 1,000 range setting. Okay, so it just takes some getting used to. You just have to pull out one of these meters and use it to get the hang of it. Okay, so the last section here, electrical safety, quite a bit involved here. So we'll stop here and come back to safety.